Welcome back to CIA Declassified. Beneath the humming lights of the National Photographic Interpretation Center, the air feels thin, as if the massive reels of magnetic tape are inhaling the room's oxygen. It is 1972. On the light table before you is a grainy black and white image of the Urals. To the untrained eye, it's just snow and iron, but you are looking for the ghost in the wires. This is the era of the energy crisis and the arms race, where every kilowatt hour produced in the USSR is a heartbeat in the war machine. You lean in closer, the scent of developing chemicals and coffee clinging to your skin, while the magnifying loop in your hand reveals a faint glowing distortion around a substation near Magnitogorsk, Magnitogorsk. It isn't light, it's the invisible leakage of a superpower's labor, a shimmering electromagnetic veil that tells you exactly how many blast furnaces are roaring in the dead of night. You feel a strange voyeuristic chill. You are looking at the literal lifeblood of a nation, watching the ebb and flow of their economy through a telescope perched 100 miles away above the atmosphere. Every scratch on the film represents a megawatt, and every megawatt represents a tank, a missile, or a hidden city that isn't supposed to exist on any map. You are witnessing the birth of vulnerability mapping. Imagine being able to see through the roof of a secret factory simply by measuring the electromagnetic interference leaking into the atmosphere. This is Project STEEP. The atmosphere in the basement of Langley is one of clinical geometric obsession. It's not about the soldiers in the trenches, it's about the copper cables buried beneath them. You feel the immense cold power of knowing exactly which transformer at the Bratsk hydroelectric station is running hot. Why STEEP? Unlike the more colorful cryptonyms of the era, Project STEEP was a descriptive designation within the Directorate of Science and Technology. The name stood for Satellite Technical Electrical Evaluation Program. It was an intelligence policy initiative designed to bridge the gap between photographic reconnaissance and signals intelligence. It wasn't just an operation, it was a permanent change in how the U.S. government assessed the industrial capacity of its rivals. If you want to understand how the agency performs a strategic EKG on a continent, you have to look at the clinical data harvested by the STEEP sensors. Project STEEP utilized signals intelligence satellites to detect electromagnetic radiation from high voltage lines. It targeted the unified power system of the Soviet Union. The project identified brownout patterns to estimate coal and oil shortages. It utilized sensors to detect the 60 hertz and Soviet 50 hertz hum of the grid. The program mapped the power requirements of the Sari Shagan anti-ballistic missile site. It utilized thermal imaging to find underground power cables. Project STEEP predicted the 1975 Soviet industrial slowdown 6 months before it occurred. The program used side-looking radar to map the physical pylons in remote regions. It tracked the activation of uranium enrichment centrifuges by monitoring frequency fluctuations. STEEP sensors detected the massive power draw of Soviet over-the-horizon radar systems like the Duga. The program identified secret closed cities by their unaccounted-for electrical load. It utilized ionospheric sounding to see how the grid affected the upper atmosphere. Project STEEP mapped the Trans-Siberian Railway's electrification. The program utilized optical sensors to count the number of lit windows in factory districts. It discovered that Soviet power grids were significantly more fragile than previously estimated. STEEP coordinated with the Office of Economic Research. The program identified the vulnerability of the Dnieper Dam system. It utilized synthetic aperture radar to see through the heavy cloud cover of the north. Project STEEP monitored the Soviet transition to nuclear power via the RBMK reactors. The program utilized tethered sensors on balloons to get closer looks at border substations. It documented the voltage drops associated with Soviet military mobilizations. STEEP was the first program to use automated load recognition algorithms. The program identified the specific power-hungry nature of Soviet laser research facilities. It utilized seismic sensors to detect the vibrations of massive turbine generators. Project STEEP was the precursor to modern critical infrastructure protection doctrines. STEEP sensors could distinguish between power used for residential heating and industrial manufacturing based on harmonic distortion. The program tracked the movement of the Soviet Baltic Fleet by monitoring the power draw of port-side degassing facilities, GAUSSING. It used the skin effect of high voltage lines to detect secret taps used by the Soviet military for underground bunkers. STEEP identified the phase shifting used to mask the true capacity of the Siberian power bridge. The project mapped the entire Guzenskaya substation network in under 48 hours, GUZHENSKAYA. It utilized plasma wave detection to find leaks in the Soviet nuclear fission research program. STEEP sensors detected the surge in power caused by the mass startup of Soviet missile silo ventilation systems. The program recorded radio frequency interference, RFI, emitted by poorly shielded Soviet transformers. It tracked the depletion of the Soviet strategic copper reserve by observing changes in grid conductivity. STEEP measured the luminous flux of major Soviet cities to calculate wartime civilian morale. The program utilized subsynchronous resonance data to identify structural flaws in Soviet hydroelectric turbines. It mapped the power grid of North Korea as a secondary, deniable testbed for the STEEP sensors. STEEP identified the power signatures of the Dead Hand Perimeter nuclear command system. It utilized atmospheric gravity wave detection to see the heat plumes rising from Soviet power plants. The project recorded the grid noise created by the Soviet Union's first primitive digital computers. STEEP identified the electrical footprint of the Soviet biological weapons facility at Stepnogorsk, STEPNOGORSK. It utilized magnetic gradiometry to map high voltage lines buried under the Arctic permafrost. The program documented the Soviet weekend dip, the significant drop in power during state holidays. STEEP sensors could detect spark discharges indicating failing insulators in the Ukrainian grid. It tracked the energy cost of the Soviet space program by monitoring the Baikonur Cosmodrome. The program used infrasound to measure the speed of Soviet turbine rotations from space. STEEP identified the power-intensive heavy water production facilities in the Soviet interior. It monitored the Soviet electrification of the Chinese border to detect troop buildups. The project recorded the flicker index of Soviet streetlights to gauge the quality of their electrical frequency control. STEEP sensors detected the electromagnetic pulse of Soviet high-altitude nuclear testing. The program utilized differential absorption to see the chemical composition of smoke from power plant chimneys. It mapped the Soviet Union's internal oil pipeline heating stations, and it discovered that Soviet power plants were often operating at 115% of their rated capacity, indicating imminent failure. The project utilized transient analysis to see how the Soviet grid reacted to sudden accidental blackouts. STEEP data was used to create a target list for U.S. Navy Tomahawk missiles. Quote from a declassified technical briefing dated 1974, "Electricity is the blood of the Soviet state. If we map the veins, we can stop the heart." Quote from a declassified memo from the Director of Central Intelligence, "Project STEEP has given us a window into the Soviet factory floor that no human spy could ever provide." A quote from a declassified report on energy intelligence, "The grid is the most honest indicator of a nation's strength." Quote from a declassified internal DS&T operational directive, "By monitoring the Soviet watt, we monitor the Soviet will." Quote from a Declassified technical manual for steep analyst, a kilowatt hour tracked is the secret revealed. Quote from a CIA intelligence assessment of the UPS, the Soviet Union is an empire built on the illusion of stability. The grid shows the cracks in that illusion. And a quote from a redacted name, former NPIC officer, we are no longer counting tanks, we are counting the sparks that build them. Within the targeting annex for strategic disruption, the section titled Cascading Failure Parameters is almost 100% redacted. Approximately 75 pages are missing. These redactions fall under exemption B1 for national security. I suspect these pages contain the critical node analysis, the exact locations of the 3 or 4 substations that, if destroyed, would cause the entire Soviet grid to collapse like a house of cards. I believe these redactions also cover cyberkinetic protocols, early plans to use electronic pulses to physically melt Soviet transformers from a distance. The missing text likely details the non-nuclear EMP research that steep data helped facilitate. And I'm not the only one with theories. When you track the pulse of a superpower, you find some strange rhythms. For instance, there's the Tesla beam theory. Some speculate that Project Steep wasn't just for mapping, but was a cover for testing directed energy weapons that could siphon power directly from the Soviet grid to power US satellites. Then there's the Chernobyl link, a persistent theory which claims that Steep sensors detected the flaws in the RBMK reactor design years before the 1986 disaster, but the US kept it secret to allow the Soviet energy sector to self-destruct. Then there's the blackout control theory. Speculation exists that the CIA actually triggered localized blackouts in Moscow during the 1970s using steep-derived data just to see how the Soviet emergency response teams functioned. Then there's the weather modification hypothesis. Some believe steep was actually used to pump electromagnetic energy into the Soviet ionosphere to cause localized droughts and crop failures, weaponizing the grid against the farmers it was meant to serve. Was Project Steep a success? Tactically, it was a revolution in non-visual intelligence. By moving beyond photography and into the electromagnetic spectrum, Steep made stealth industry impossible. The agency could see through concrete and camouflage by following the electrons. It proved that in modern economy, the power cord is the ultimate snitch. It allowed the creation of a real-time economic map that adjusted with every shift of a turbine. This gave the U.S. military the ability to perform precision attrition, knowing exactly which parts of the Soviet industrial chain were under the most stress and where a minor disruption would cause the maximum delay. It turned intelligence from a snapshot into a live stream, providing a tactical edge that redefined the meaning of total awareness. Furthermore, the success of Steep was found in its ability to identify non-obvious targets. Before Steep, a forest was just a forest. After Steep, a forest with a 500 kilovolt line disappearing into it became a high-priority search zone for nuclear research. This capability effectively stripped the Soviet Union of its vast geographical advantage. No matter how deep into the lab they went, they couldn't hide the heat in the hum. The program was a masterclass in signatures intelligence, teaching the agency that the most valuable information isn't what people say, but what their machines do when they think no one is watching. Strategically, it shifted the Cold War from balance of terror to a balance of infrastructure. It allowed U.S. planners to move away from total nuclear annihilation toward surgical strategic disruption. Steep gave the U.S. a way to win a war by turning off the lights rather than burning down the house. Strategically, it was the first step toward the modern cyber war doctrine, where the most important battles are fought in the control rooms of utility companies. By identifying the fragility of the Soviet grid, it gave U.S. presidents a third option between doing nothing and launching an all-out nuclear strike. This strategic flexibility likely prevented dozens of close-call escalations by providing non-lethal ways to demonstrate power and resolve. Strategically, however, Steep also began a dangerous infrastructure arms race. Once the Soviets realized their grid was being mapped, they began to build redundancies and decoy loads that cost billions of rubles, further straining their failing economy. While this accelerated the collapse of the USSR, it also created a precedent for targeting civilian life support systems. The strategic success of STEEP established the modern reality where the electrical grid of every nation is considered a legitimate theater of war. It moved the front line from the border to the fuse box in every home, a strategic shift that humanity is still struggling to reconcile with international law. As far as technological and operational breakthroughs go, Project STEEP led to quite a few, such as remote infrastructure monitoring, which was pioneered to track Soviet transformers from space and is now the global standard for smart grid technology. Humanity uses this daily to automatically reroute power during storms, preventing mass blackouts, and allowing for the integration of unstable green energy like wind and solar. In solar, the military applies this to autonomous base management, where AI monitors power draw to hide a base's signature from enemy satellites. The intelligence community uses it to detect crypto mining farms or secret industrial facilities by identifying unique electrical heartbeats in the global grid. Electromagnetic signature analysis was refined to identify Soviet factories by their electrical noise and has evolved into industrial diagnostics. For humanity, this allows for predictive maintenance, where hospital and factory equipment can tell technicians they are about to fail weeks in advance by changes in their electromagnetic output, saving lives and billions in cost. The military uses it to identify enemy vehicle types through walls or foliage based on their ignition systems. The intelligence community uses it to fingerprint foreign hardware, identifying exactly where a piece of tech was manufactured by its unique interference pattern. Thermal anomaly detection was perfected to find buried Soviet cables and is now the core of energy auditing and climate science. Humanity uses it to find heat leaks in homes to reduce carbon footprints and to track the movement of forest fires through thick smoke and darkness to save lives. The military uses it to identify hot spots in underground bunkers or hidden engine rooms. The intelligence community applies it to satellite forensics, identifying which buildings in a foreign compound are occupied or housing high energy equipment like servers or labs, even if they appear dormant to the naked eye. And automated load forecasting was created to predict Soviet industrial output and is now the engine of global energy markets. Humanity uses it to predict when cities will need the most power, allowing for the efficient distribution of electricity and preventing grid collapses during heat waves. The military uses this math to manage energy security for carrier strike groups and remote outposts. The intelligence community uses it for economic intelligence, accurately predicting a rival nation's GDP or wartime manufacturing capacity months before official numbers are released, simply by watching the surge and dip of their national grid. We live in a world defined by the electrical frontier. Project STEEP was the moment we realized that the grid isn't just a utility, it's an autobiography of a nation. It was a project that turned the mundane hum of a transformer into a high-stakes intelligence asset. The reality of STEEP is that it made the invisible visible. It proved that a superpower is only as strong as its weakest circuit. This project established the precedent that in the age of technology, privacy doesn't exist for any entity that needs to plug into a wall. As you sit in your home tonight, surrounded by the quiet hum of your appliances and the soft glow of your screens, remember that you are part of a giant pulsing map that never stops broadcasting. Every time you flip a switch, you are sending a signal into the vacuum, a tiny digital flare that says, "I'm here and this is what I'm doing." Steep taught us that the modern world is a circuit, and in a circuit, there is no such thing as a secret. We are the first generation of humans whose history is being written not by ink, but in the flickering lights of our cities, recorded by silent sentinels that have been watching us since the days of the Cold War. The electric frontier didn't just map the enemy, it mapped the future of us all, a world where the grid is the only witness that never lies and never sleeps. When you flip a switch, you are broadcasting your existence to the world. The most important map of a city isn't its streets, but its wires. If you want to hide, you have to go off grid. And remember, power is only power until someone knows where the fuse box is. Next time, we're going to be examining MK Cobalt, the CIA's disturbing research into using radiation as a tool for behavioral modification. We'll look at the invisible whip, the science of atomic control, and the dark legacy of a war fought with the very fabric of the atom. Join us next time for The Radioactive Mind. In the meantime, I'll see you in the archives.